So I is the square root of negative 1. The converse of that is that I squared is negative 1. I know that's a leap for you, but that's the basic premise that you have to accept. Okay? What this means is that I cubed is I squared times I. And since I squared is negative 1, I cubed must be negative I. I to the fourth is I squared times I squared. We know what I squared is. By definition, it's negative 1. Negative 1 squared, negative 1 times negative 1 is equal to 1. Continuing on, I to the fifth has to be I to the fourth times I. We know that I to the fourth is 1. 1 times anything is itself, so I to the fifth is 1 times I, which makes it I. Okay? That in and of itself wasn't too difficult for anybody to follow, I don't think, but the problem is that you didn't get, a lot of people had issues with the pattern. Every time you go through this, I to the 8th, I to the 12th, I to the 16th, I to the 28th, I to the 440th, I to the 3612, all equal 1 because they're multiple. The exponent is a multiple of 4. Okay? I to the 9th, 1 more than 8. I to the 13th, 1 more than 12. I to the 17th, 1 more than 16. And any I that is 1 more exponentially than a factor of a multiple of 4 is going to be equal to I, because 1 times I is I. The pattern continues. So I to the 10th is 2 more than I to the 8th, and since I to the 8th is equal to 1, this is going to be the same as I squared. What's I squared? Negative 1. That's the pattern that you have to recognize, and I'm going to quickly, again, I'm not going to stop. So, but looking at this, how do we find out what I to the 210th is? Well, we divide 210 by 4. 210 divided by 4 happens to be 52 with a remainder of 2. So this is going to be the same as I squared, because it's the same as I to the 208 times I squared. And since I to the 208 is equal to 1, and I squared is equal to negative 1, this equals negative 1. I to the 1,201, okay, happens to be, do you know that 4 times 300 is 1,200? Okay, well, 1,201 is 1 more than that. So this is the same as I to the 1,200 times I to the 1. And since I to the 1,200 is equal to 1, I to the 1,201 is equal to I. 3,603. 4 times 900 is 3,600. This is 3 more. Let's go back. What's I to the third? Negative I. Okay? So since I to the third is negative I to the 3,603 is also negative I. Okay? That's a quick review. Now, multiplication and division. Multiplication of two complex numbers. Just as though this I was an X or a Z or a Q, you FOIL this out. 6 times 3, 6 times negative 2I, 5I times 3, 5I times negative 2I. Understand? You got 4 terms. Well, the middle 2 are like terms. Negative 12I and a positive 15I becomes a positive 3I. And since I squared is equal to negative 1 by definition, we have 18 plus 3I minus 10 times negative 1. So this ends up being plus 10. And our solution, our product, is 28 plus 3I. These two binomials, this one and this one, multiply together to form this. These two complex numbers multiply together to form this. Now, if this is true, if 6 plus 5I times 3 minus 2I equals 28 plus 3I, then shouldn't 28 plus 3I divided by either one of these factors equal the other? That's the tricky one. This is the sort of the culmination of the skill set that we're sort of insisting that you master. Okay, let's show how you divide complex numbers. There's one little new vocab thing that's called the conjugate. Okay, this is my division problem right here that I'm trying to solve. 28 plus 3i divided by 6 plus 5i. I'm going to go ahead and put parentheses around that. In order to solve a division problem of complex numbers, I multiply by a form of 1. That form of 1 is the conjugate of the denominator divided by the conjugate of the denominator. Okay, bear with me for a minute and hopefully that will come clear to you. The conjugate of 6 plus 5i is 6 minus 5i. When I FOIL those out, just like with the difference of two squares, I end up with this. 6 squared minus 30i plus 30i, gone away, minus 25i squared. And since we know that I squared is negative 1, this ends up as 36 plus 25, or 61. FOIL out the top, and we get these four terms. Combine like terms, like I have here. Realize that I squared is negative 1. You can change colors so you can see this a little better. Okay? And all of a sudden you have 168 plus 15 minus 122i, which is 183 minus 122i. And guess what? 183 divided by 61 is 3. 122 divided by 61 is negative 2. I have what I would hope to have as the quotient of 28 and 3i plus 3i divided by 6 plus 5i. Okay? Quickly, what do we do? Okay, I'll show you very quickly what you do. Okay, we're going to multiply by a form of 1. That form of 1 is going to be the conjugate of 7 plus 3i, which is 7 minus 3i. 7 minus 3i. Okay? 7 plus 3i times 7 minus 3i is going to be 7 squared minus 3i squared. So it's 49 minus 9i squared. This FOILs out, just like any other pair of binomials, to 35 minus 15i minus 21i plus 9i squared. Okay? Negative 15i and negative 21i give me a negative 36i. 35 minus 36i plus 9i squared, which is 9 times negative 1. Okay, so it's going to end up with, and this is 9 times negative 1, so it's 49 plus 9 is 58. 35 minus 9, 35 minus 9 is 26. And I am nearly done, except they're all even, so I could simplify it as such. I could do 13 over 29 minus 18i over 29, or 18 over 29i. That didn't work out neatly, but that's how we divide complex numbers. That's it. That's all I'm going to do for right now.